Okay, good, guys. No talking. All right, good. Okay. So, welcome to our session number 4. Good. So, what have we learned so far uh, in this part of the module? So, we have looked at valuation of assets. We have looked at we started talking about portfolio creations, right? Okay. So last week, I introduced you to this portfolio theory, and we looked at the effect of diversification. So I spent a lot of time trying to explain to you why diversification would work and in which cases it may not work. Right? So one of the things that we covered in some detail is that diversification helps to minimize risk, but it only helps to minimize risk when the assets that you select in your portfolio are not perfectly correlated. Diversification benefits would be greatest when assets in your portfolio are perfectly negatively correlated, right? But you will still have some benefits of diversification even if those assets are not negatively correlated. As long as they are not perfectly positively correlated, you will still have benefit of diversification. So diversification will help to reduce the risk of the portfolio. So we have covered the main theory of it. So the plan for today is that I'll go through some examples with you relatively quickly because I've covered all of the theory, right? I've conveyed all of the main concepts. So we'll go through this session relatively more quickly, but in case you have any questions or if something is unclear, feel free to stop me, right? Okay, so we in the last session at the end we started talking about this definition of formal definition of portfolio, and we looked at creating a portfolio using two assets as an example. So I showed you this slide in the last session. So what is the expected return of the portfolio? The expected return of the portfolio is simply the weighted average of the return of individual assets in your portfolio. Okay, good. So the return is the weighted average, right? As you can see in this slide, return of the portfolio is simply the weighted average return of the assets, individual assets in your portfolio. Okay, so here's a quick example to show you how the portfolio return, how you can calculate portfolio return. So let's say we have two stocks D and E. The return of stock D is 8%, and return of stock E is, so here we're talking about expected returns. Stock E expected return is 13%. So if you put 50% in each of these two assets, we can calculate the portfolio return, which will be simply the weighted average. So weight of your investment in asset D times the expected return of asset D plus weight of your investment in asset E times the expected return of asset E. Okay, so expected return of this portfolio, which consists of 50% investment in D and 50% investment in E, would be 10.5%. Okay, so for portfolio expected return is simply the weighted average. Okay, but you can see, so again, so here you can see you can create multiple of these portfolios depending upon how much you're going to put in each of these assets, right? So what is the range of the portfolio expected returns? What is the range of portfolio returns? How many portfolios can you create using these two assets? Okay. How many portfolios can you create using these two assets? Give me any number. 99. Good. Anybody else? One. Okay, we have one already, right? Okay, anybody else? One and 99. Anybody else? You can create, enormous number of portfolios, right? How you can create enormous number of portfolios using these two assets? By simply changing the weight, right? So you can have like 1% in D and 99% in E, and then 2% in D and 98% in E, and then 14.5% in E, and the remaining in E, right? So you can create a large number of portfolios, right? But each portfolio would have its own expected return. Okay, so in this example, 50% in D and 50% in D gives you an expected return of 10.5%. But if you change this percentage investment, if you change the weights, the expected return of the portfolio will also change, right? So you can think about this portfolio as a new asset, right? A new asset. So by changing these weights, you can create multiple portfolios, which will have their own expected returns. Okay, so now you can see there are two factors that you need to pay attention to when creating portfolios. What is the first important factor? The correlation between assets, right? That's what we covered in the last session in quite some detail. That portfolio creation will result in risk reduction only if assets in your portfolio are negatively correlated or less correlated, right? But the other factor that now we have identified that can potentially affect expected returns is the weight. So you would also have to decide. So the first question was which assets to select in your portfolio. And the answer to that would be based on the correlation between assets. Okay, so once you have identified the assets, the next step would be how much you're going to put in each asset. Okay, so that's what we are going to look at. So portfolio, so we can, as I told you, we can create multiple portfolios by simply changing the weights. So here I've like listed five of these. So if you put nothing in D and everything in E, your expected return would be 13%, which is equal to the expected return of E. Okay, on the other extreme end, you can put everything in D and nothing in E. So your expected return in that case would be equal to that of D. And then in between these two, you can create, a portfolio expected return based on how much you're going to put in D and E respect. Okay, good. Good. So what we have concluded here, you can create a range of portfolios simply with two assets, simply by changing the weights. Okay. Right. So let's look at the risk part, which is more important, right? Because the reason we want to create portfolios is because we want to reduce our risk. Okay. So we measure risk through variances or standard deviation. So we can calculate the variance of this portfolio as well. But here you can see the variance of this portfolio is not the weighted average. Okay, there is an additional term here, right? Okay, and that takes into account the covariance, and the covariance depends upon the correlation between the assets. So rest of the terms are you're familiar. So weight, WD and WE represent the weight in stock D and E respectively. Sigma D and sigma E, these represents variances and variances of stock D and E. And the most important term here is the covariance, right? So the covariance between stock D and E will determine what will be the variance of the portfolio, which consists of stock D and E. Okay, and as I showed you this earlier, so this covariance depends on the correlation between the two stocks. Right. So we know covariance. So we know that correlation has a range from -1 to +1. -1 perfectly negatively correlated. 0 means uncorrelated. The two assets are uncorrelated, and +1 means that the two assets are perfectly correlated. Okay. So which correlation would be desired, right? You should only know the answer to this. So which correlation would you prefer in your stocks? If you have to select stocks, which stocks will you choose? The ones which have a correlation of minus 1, right? And then I told you in practice, it's very, very difficult to find assets which are perfectly negatively correlated. So the best thing you could do is to find assets that are least correlated. Okay, good. All right. Okay, so let's look at the portfolio variance using the same example. Right. So we not the same example, but an example, right? Because I changed the. Okay, so here we are looking at standard deviation, right? Or the risk. So we're looking at standard deviation as a measure of risk. So standard deviation of stock D is 12%, standard deviation of stock E 20%, and given that in our example we are putting 50% in D and 50% in E, right? So these are our weights in this portfolio. And if I give you the covariance, so the covariance between the two stocks, D and D, is given as follows. Okay, guys, no talking. All right, guys, no talking. You two are really distracting me. Okay. Right. Okay, so the covariance between these two stocks is given, and there is a measure of correlation as well. So now we can calculate, given this information, we can calculate the covariance. Given this covariance or the correlation, so as long as you have one of these two, you should be able to calculate the portfolio variance. Okay, so we can calculate the portfolio variance to be 0.0172, and if we convert that into standard deviation, all we have to do is to take the square root of it, and it gives us 13.11%. So the expected return of this portfolio was 10.5%, right? Okay, 10.5% with 50% in D and 50% in E. The risk of this portfolio turns out to be 13.1%. Okay. But as I told you, we can create multiple portfolios, right? Simply by changing the weights. So given the changes in weights, the expected return of the portfolio will change, and with the weights, the risk of the portfolio will also change. So here, using the same uh, weights as I showed you earlier with respect to calculation of portfolio returns, so I have added another column that shows you the portfolio risk, right? So portfolio standard deviation, as we can see, is smaller in cases when we put 70% in stock D and 30% in E, or 80% in D and 20% in E. So you can see in these two cases, when the weights are these, right, the portfolio standard deviation is lower than the individual stocks as well. So this gives you some idea, how much should you put in stock D and E, right? Okay. But the most important point here is, as we change weights, the point of this example is, as we change weights, the portfolio return, expected return will change, and so will its risk. So, so now we have identified two main factors that we need to pay attention to when we are creating portfolios. Number one, the correlation between assets. Number two is how much we are going to put in each asset. Okay, good. Right, so this is a graphical representation of what I just explained. So using so it's essentially the same problem, but represented in a graphical format. So here we have two assets, uh, stock D and E. So on the horizontal axis, I have plotted the risk of the portfolio, so portfolio standard deviation. Did I say horizontal or vertical? On the vertical axis, we have portfolio standard deviation, and on horizontal axis, what I'm going to do, I'm going to change the weight I'm going to put in one of these stocks, right? So on the horizontal axis, it's the weight in stock E. So what will be the weight in stock D? Whatever 1 minus whatever the weight is, whatever the weight of stock E. Okay, good. So based on the based on our example, if I put everything in stock, uh, if I put everything uh, in stock D, right, I will have a portfolio standard deviation equal to something around 12%, right? You can see the spot, the dot on the vertical line. Okay. On the other hand, I could put everything in stock E, and then that would be, where weight of stock E equals 1, that would be the standard deviation of the portfolio in this case. But essentially, it's not a portfolio because I have put everything in stock E. So for the purposes of this example, if I call it a portfolio, it means the portfolio risk will be equal to the risk of stock E. Right. So you can see this is, there's a straight line. Okay. So, but the risk reduction will depend upon the correlation between these two assets. So these blue lines, light blue lines, show the effect of diversification when you have different correlation. Okay, so these blue lines, right, show you what would be the risk of portfolio as you change weights, right? Okay, so the blue lines show you the risk of portfolios, different portfolios, as you change weights of stock D and E. Good. Okay, so when the correlation is 1, what do we see? There is a straight line, right? Okay, you would go from point, the first dot on the vertical axis to this point where you have everything in stock E, right? So there is a straight line. There is no risk reduction in this case, right? Okay. But as you change the correlation, so this is an example where you have perfect correlation, right? Correlation equals 1. So there is a straight line, right? No risk reduction. But as you change correlation, right? So let's look at where correlation equals 0, for example, right? It's the dotted line. And you can compare this with this solid blue line where the correlation is 0.3. So where correlation is higher? With the solid line, right? Of 0.3, and it's less when it's equal to 0. Okay, so if you look at this, if you look at these two lines, as correlation, the lower the correlation, the greater is the risk reduction. Okay, where correlation is equal to 0, you can see we have the dotted line is the lowest compared to the solid line, right? So the benefit of diversification, this signifies the benefit of diversification will be greater when you have when the correlation between assets will be negative, or when the two assets are least correlated. And as the correlation increases, the benefit of diversification will disappear. And the other extreme example here we have is when the correlation is -1. When the two assets are perfectly negatively correlated, we can essentially eliminate all risk. Okay, so you can see risk goes down to 0 when the two assets are perfectly negatively correlated. But as I mentioned, in practice, it's difficult to find assets which are negatively correlated. So the key point here is that what you need to take into account, the correlation between assets and how much you're going to put in each asset to create the portfolio. So if you are putting more weight in stock E, right? If you put more weight in stock E, or you get closer to stock E, but 90% or 78% or 95% or whatever. So irrespective of the correlation, right? Irrespective of the correlation, you're getting closer to that point, closer to this point here on the slide. I'm not sure if it will capture the video will capture this cursor or not. But the closer you get to 100% investment in stock E, the more closer to you're here. So the risk reduction will depend upon two things: correlation and how much you're going to invest in each stock. Okay, so this is another way to look at the same thing. In last session, I showed you this. Uh, uh, I showed you the curve, right? That shows how much you that shows the combination of all the portfolios that you can create given the number of assets that you are that you have at a particular point in time, or that you're considering in your portfolio. Okay, good. So again, in this case, what I've done, I have combined risk and return in this portfolio. So on the horizontal axis, we have the standard deviation measuring the risk, and on the vertical axis, I have the expected return of the portfolio. Okay, and as I told you, you can create multiple of these portfolios by simply changing the weights. So each point here, each point on these lines represents a portfolio, right? And that point would be based on how much you're putting on each of those assets. So if you put everything in stock D, right? If you put everything in stock D, what would be the expected return? What is the expected return of stock D? It was 8%, right? Okay. So if you put everything in stock D, you are at this point D here. Okay. So your expected return is 8%, and the risk of stock D is 12%. And if you put everything in stock E, which is here, right? Okay, so your expected return is 13%, but the risk of investment in stock E is 20%. And this solid black line represents the combination of these assets as you change weights. So you can create multiple portfolios by changing the weights. Okay, so this solid line is a scenario where there is no benefit of diversification. Okay, two assets are perfectly correlated, so there is no benefit of correlation. As you move to, as you put more investment in stock E, you get closer to this point E. Okay, and as you put more investment in D, you get closer to point D on this line. But given that these two are perfectly correlated, the correlation between these two is 1, so there is no benefit of diversification. Okay, but as you change correlation, okay, so let's look at this scenario where correlation is 0.3 between the two assets. So again, this yellow line is similar to this solid black line, except that in this case, the correlation between the two assets is different, right? These two assets now are less correlated. So you will see some benefits of diversification. Right, so if we look at this point here, can you see my cursor on this? Here. No, you can't see it on the slide, right? Okay, let's see if you can see it like this. Okay, yeah. Can you see this point here? Right? So what do you see here? What is the expected return here? You can just draw a line parallel to see what would be the expected return. It should be around something around 10%, right? And what is the risk at this point? Less than 12%. Right? So you can see we are using still the same two stocks, right? But our risk has gone down. Okay, if we put everything in stock D, our risk was 12%. But by combining these two assets, we can create a portfolio set that gives us higher return, higher expected return, but our risk has gone down. So we we can still earn. So if you compare this point D, compare this point here with that of D, which portfolio will you select? Will you select this point D, or will you select this point here? Okay, so you should all select the point here, right? Because this gives you a higher return for a lower risk, right? And the next line shows where, the dotted line shows where the correlation is 0. So you will have greater effect of diversification because you have moved from less correlation to uncorrelated. Good. Okay. So you can see this curve moves even backwards. So you can get even a higher return for even a lower risk. You can get higher return for by reducing the risk further, right? Okay. Good. Okay. So the curves that we are talking about here is what we call the efficient frontier, right? So I introduced this in the last session as well. So what is this efficient frontier? So this shows the combination of all the different uh, assets. It shows the highest possible return that you can earn for a given level of risk. So you can create an infinite number of portfolios by combining different assets. So all these dots on this slide represent a portfolio, right? And these are different portfolios, and you can create these different portfolios by simply changing the weights. Okay. So if you have to select a portfolio from this slide, which point will you select? As I said, each point represents a portfolio, right? So you can create all these different portfolios, but you cannot go above this efficient frontier. So points above the efficient frontier are unattainable. But below this line, you can create, as many portfolios as you want. As I said, each point represents a portfolio here. So, if you look at this slide, right? Do you have a preference for a particular portfolio? Assuming each dot is a portfolio, right? Do you have a preference? Which portfolio would you want to choose? Anyone? Yeah. You will choose the minimum variance portfolio, the red dot, right? Okay. Anybody else? So let's just quickly define the minimum variance portfolio. So minimum variance portfolio is a point that it's a portfolio basically that has the lowest variance. Lowest variance. So as I said, all of these point dots are portfolios. But which of these portfolios has the lowest variance, lowest risk? That is what we call as the minimum variance portfolio. Okay, so you'll go for minimum variance portfolio. Anybody else? Anybody else wants to choose a different portfolio? No? Okay. Okay. Nobody will choose any other portfolio, right? But so the next thing we are going to look at is the risk preferences, okay, which we'll cover partly in this slide and part in this session and probably in the next session. Okay, so you can create any portfolio. Anybody who would, okay, let me just actually point to things, point to these portfolios and then ask. So anybody who would prefer, let's say, this portfolio? Anybody has a preference for this portfolio? No? No one? Okay, this one? Still no, right? Okay, or you don't know. This could be the other possibility that you don't know, right? Okay, so what is your objective? What do you need to do, right? The objective of creating portfolios is to reduce the risk, right? So just take any 2 points, right? Any 2 points. So on the vertical axis, we have expected return of the portfolio, and on the horizontal axis, we have the risk of the portfolio, right? So let's say we take this point, You can't see it. Okay. So let's say we take this point, right? Okay. So this portfolio, what is the expected return? If we just draw a horizontal line, that will give us the expected return of this portfolio, right? Okay. And if we draw a vertical line, that will give us the risk of this portfolio, right? Okay. But if you look at this, we can choose this portfolio as well, right? These two are vertical, right? Okay. So we can either choose this one or we can choose this one. Okay, let's call this one A and let's call this point B. Okay, so now do you have a preference for A or B? Yes. Which one would you prefer? You would prefer B, right? Very good. Okay, why would you prefer B? Because this B has the same risk with the same risk, but it offers a higher return, right? Okay, so which means what is your objective? You would want to be as closer to this efficient frontier as possible. Okay, because for the same risk level you are getting the higher return. Okay, good. So when you are creating portfolios, what is your objective? To be as close to this efficient frontier as possible. And because this efficient frontier means it is a point. You know, if you select any point on this efficient frontier, that would represent a portfolio that gives you the highest return for a given level of risk. Okay, for a given level of risk, because as we move along this line, the risk also changes, right? But at a particular point, at a particular risk level, this is the maximum return that you can achieve. Okay, so your objective would be to create a portfolio which is as close to the efficient frontier as possible. But there are people who would choose a minimum variance portfolio. That simply means they are more risk averse, so they would like to reduce the risk. Okay, so if you look at this minimum variance portfolio, its expected return is somewhere here, right? But its risk is also lower. But you can choose a point, for example, here. If you're taking on more risk, we know with higher risk, you should expect to earn a higher return. So the return is higher as well. Okay? Good. All right. Okay, good. So we have seen, how correlation affects the portfolio return and risk. The effect of diversification would be greatest when the correlation between the two assets are when the two assets are negatively correlated. Okay. So now, so we briefly, I define this, what is minimum variance portfolio, right? So we can create this, we can create this minimum portfolio, right? So what do we have to do? We have to so the correlation between the two assets is given, right? We can't change that. But what we can change is the amount of investment we are going to invest in each of these two stocks. So we can calculate the amount of investment we are going to make in, let's say, stock D to get to this minimum variance portfolio. So the formula for this is here on the slide. Okay, so what are we doing here? We are trying to get to that minimum variance portfolio, but in order to get to that point, in order to achieve that minimum variance portfolio, we need to decide how much of our investment should go in stock D and how much of it should go in stock E. Right? So what are we going to do? We are going to calculate the weight or amount of investment we are going to put in stock D. And if we know how much we're going to put in stock D, right, the rest would go in stock E. So that's why weight in stock E is simply 1 minus whatever we are going to put in stock D. Okay, and we know the sum of the two weights must equal to your investment representing 100% or 1. Right. Okay, so we apply this formula to our example, right? So these are numbers from the example that we are using. So the weight of stock D should be 0.82 or 82%. So we should invest 82% in stock D and the remaining 18% in stock E. So as long as we invest 82% in stock D and 18% in stock E, we will have a portfolio which will have the lowest risk, right? And we call it minimum variance portfolio. So we'll have a portfolio with the lowest risk, but that would depend upon how much we are going to invest in stock D and E. Okay, good. So to get to that minimum variance portfolio, we must invest 82% in stock D and 18% in stock E. And that's what I've done here. So we invest 82% in stock D, 18% in stock E. The expected return of this portfolio is around 8.9%. But more importantly, the risk is only around 11.44%. So which means working with these two assets, stock D and E, the lowest risk that we can attain is 11.44%. We cannot go below this. Okay, that is the minimum uh, risk portfolio that we can create with these two assets. Okay, and you can see any other combination of these two assets using different weights, right, will give you a portfolio risk that is higher than this minimum variance portfolio. Good, okay. So the next thing I'm going to show you is if we have more than two assets, right? We're not going to do calculations for this because it would get a bit complicated, but I'll show you as you increase the number of assets, how it affects your portfolio and what factor becomes more important. So calculations, as we know, may become a bit more complicated with portfolios that have more than two assets. So if we look at this example of three assets, so this is how our formula would look like. So you can see, in terms of expected return, it's quite simple because it's simply the weighted average. But when it comes to variances, when it comes to risk, it depends upon the covariances between the assets. So if we have three assets, we have to look at the covariance between 1 and 2, covariance between 1 and 3, and covariance between 2 and 3 as well. Okay, but if we increase the number of assets in a portfolio, so suppose we have a portfolio with n assets, and we assume that we have put equal weights in each of these assets. Okay, so with equal weights, how much we are putting it in each asset? 1 over n, right? Okay, so in this case, the portfolio's average variance can be calculated using the formula that you have on the slide. But if you look at this, okay, so 1 over n is simply the weight, right? And then we have variance of stocks from I to J. Okay, so there is some overlap here, so it might not be as clear in the slides, but what it says is the variance of stocks from I to J. If you have I to J assets. Okay, so this is the first term. Then what the next term we have is the average covariance. Okay, so n minus 1 over n times the average covariance. Okay, so n here represents the small n here represents the number of assets in our portfolio. The sigma square from I to j represents the average variance of all assets in the portfolio, and the last term is the average covariance of all assets. Okay, so what I want you to think about, okay, if you take this formula, right? And all I want you to think is if you have n that is large enough, if n is large enough, right? So how this would affect the first term here? So n is in the denominator, right? If n is large enough, this first term would become close to 0, right? Because n is too large. So you're dividing it whatever is the average variance, you're dividing it with a very large number, right? So it would become close to zero. So when you have a portfolio with a large number of assets, the only relevant term is the covariance. Okay, so the first term becomes close to zero, and the only thing that's relevant in that case is the second term, n minus 1 over n times the average covariance. Okay, right. So this is what happens when you diversify. Okay, and when you have a large number of assets in your portfolio. So I showed you this slide earlier as well. So this is an example of international diversification. So this blue line represents the uh, risk reduction when you only invest in U.S. securities, right? But as you diversify internationally, you can see your risk reduction. Uh, you have greater benefits of diversification, and your risk goes down further. Okay, so the benefits of diversification. What can we conclude from what we have learned so far? So when you create a portfolio, the reason you want to create a portfolio is to reduce risk. And in order to create a meaningful portfolio that results in risk reduction, the factors that you need to take into account are the correlation between the assets that you're selecting in your portfolio. And the next important factor is how much you're going to put in each of those assets that you have included in your portfolio. Right, good. Do you have any questions here before we move on to the next session? Next part, basically, not next session. Any questions so far? No? Good. All right. Okay. Good. Right. Okay. So this is the last part in the portfolio theory. Right. Okay. Good. So just again, quickly summarizing what we have covered so far, right? Because we need to build on this. Okay, so we introduced this portfolio theory. We know what portfolio theory is. So we can create an optimal portfolio by combining different assets, right? And the factors that we need to look into when we are creating portfolio, we need to look at the correlation between the assets, and we need to look at how much we are going to put in each of those assets, right? I told you in practice, it's difficult to find assets that are perfectly negatively correlated. So you need to look for assets that are either less correlated or uncorrelated. Okay, and in that case, we'll have the greatest effect of diversification. So we looked at calculating portfolio expected risks and expected return, right? You know, we looked at an example to calculate expected risk and return using the following formulas, where we use two assets in our example. Right, we defined what is an efficient frontier. Efficient frontier is a frontier or is a curve that shows the maximum return that you can achieve for a given level of risk. And within the efficient frontier, the lowest point, which has the lowest, the portfolio which has the lowest risk is what we define as the minimum variance portfolio. Okay, so again, now coming back to the practicality of it, right? So if you, as an investor, have to create a portfolio, right? So how can you create an optimal portfolio? A portfolio that gives you the highest risk, highest return for the given level of risk. Okay, and I keep on saying for a given level of risk because that depends upon risk preferences. Okay, good. Okay, so questions that we are going to answer now are the following. Are all portfolios along the efficient frontier optimal? Okay, can you answer this question? If you have a portfolio, if you select a portfolio on the efficient frontier, can we call it an optimal portfolio? Yes or no? Okay, let's see if we have, no, we don't have a curve here. Okay, so as long as a portfolio is on the efficient frontier, is it an optimal portfolio? What is an optimal portfolio? That gives you the highest return for a given level of risk. Okay, so can you achieve a point above this optimal portfolio, above the efficient frontier? That's not possible, right? You cannot go above the efficient frontier. So which means any point on the efficient frontier is the optimal portfolio. Okay, and all the portfolios lying below it will not be optimal. And that's what I said earlier. So your objective is to be as close to the efficient frontier as possible, because that will give you the highest possible return for a given level of risk. Okay, so the next thing we'll look at is the capital allocation line, and we'll define the Sharpe ratio and how can we construct an optimal risky portfolio. So we'll first construct an optimal risky portfolio. Okay, so that will be our first objective. How can we create an optimal risky portfolio? Our objective here would be to maximize the Sharpe ratio, and we'll define what Sharpe ratio is. So in order to create an optimal portfolio, right, we need to create an optimal risky portfolio. The next thing we need to do is to combine it with a risk-free asset. And once you combine the optimal risky portfolio with a risk-free asset, that is what we call as optimal complete portfolio. Okay, so how do we get from optimal risky portfolio to optimal complete portfolio? We'll cover that in this session and part of the next session. Okay, good. So portfolio with risky assets, right? With the risk-free asset. So far what we have done, we have two assets, stock B and stock E, right? And we combine them into a portfolio. What stock D and stock E were risky assets, right? They had a standard deviation. They had a variance, right? Okay, so what we have been doing so far? Combining these risky assets, stock D and stock E, to create different portfolios, but that is still a risky. The two assets are risky assets. Okay, so we have been combining only the risky assets. But here, and we are going to include a risk-free asset, and once we include risk-free asset, we call it the complete portfolio. So in addition to investing in only risky portfolios, as in the previous part of this session, previous lecture, and part of the earlier part of this session, investors can also add a risk-free asset to form what we call as the complete portfolio. But do we have risk-free assets, right? Do we have risk-free assets? Well, what are risk-free assets? Do we have risk-free assets? Yes? No? Yes? Who is saying yes? Okay, anybody? Do we have risk-free assets? Yes. Good, very good. Okay. Which is a risk-free asset? Treasury bills. Right? Treasury bills. Treasury bills are treated as risk-free assets. These are not risk-free, but these are close to risk-free. Okay. So yeah, let's say if you have a treasury bill from a country that's close to bankruptcy, would you call it a risk-free asset? It's no longer a risk-free asset, right? Okay. But we use treasury bills as risk-free assets or approximation of risk-free assets. Okay, good. So how would investors, so if now we have a risky portfolio and a, and a proxy of risk-free asset. Okay. So the next question now would be, how would you allocate your resources, your investment between the risky portfolio and this risk-free asset? Okay. So the mathematical abbreviations and derivations is identical to what we have seen earlier with two risky assets. So the only difference here is the other asset here is a risk-free asset, and the risk of a risk-free asset is close to zero, right? So given that we are working with T-bills, and we can assume that the risk of these T-bills is zero. Okay. So if you look at this setup, this is similar to what you have seen earlier, right? With stock D and E, right? Okay. The only thing I've changed here, I have replaced stock D and E with a portfolio because both stock D and E were risky assets. So here I've combined them into a portfolio, and as I told you, portfolio itself is an asset, right? You can treat portfolio as a new asset. So we have a risky portfolio as one of the investments options, and a risk-free asset as another investment. Right, so expected return of the portfolio, we can calculate that, right? Which we have done just a few minutes ago. And then we have a risk-free asset. The rate of return of the risk-free asset is already known, right? Because you know, or you can calculate the rate of return on the T-bills. Right. Okay. So what do you have to do now? You have to determine the weights that you're going to put in the risky asset and the amount of money from your total investment that you're going to put in the risk-free assets. So the term YP represents the weight of your investment in the risky portfolio. So YP is the investment in the risky portfolio. 1 minus YP is whatever is left, right? That would go into the risk-free asset. Right. So it's a simple formula, right? So so if I treat the risky portfolio as asset one and the risk-free asset as the asset two, right? So the expected return of this complete portfolio would simply be the weighted average, just like in the previous example of stock D and E, right? So what do we have here? Weight in the risky portfolio times the expected return of the risky portfolio plus weight in the risk-free asset times the expected return of the risk-free asset. Okay, so that gives you the expected return of the complete portfolio. Okay, so we can simplify this, right? If we solve this, we get to this equation where expected return of this complete portfolio is equal to the weight in the risky portfolio times the excess return of the risky portfolio above the risk-free rate plus the risk-free rate. Okay. Okay. Good. Does this red equation look familiar to you guys? Can you think of any other equation this resembles to? The the CAPM, right? This looks similar to CAPM, right? Okay. Good. So when you combine a risk-free asset and a risky portfolio, you have a formula of expected return that looks like CAPM, right? Okay. So what is the expected return of this complete portfolio? It's the risk-free rate plus the the expected return above the risk-free rate because you have chosen to invest in a risky portfolio. Okay, and the expected return of this excess return will depend upon the riskiness of the portfolio that you have chosen. Right. So this is the weighted average return of the two assets, right? One of is a risky portfolio, the other one is a risk-free asset. So using the same formulas that we've learned, right, we can create, we can calculate the risk of this portfolio, risk of this complete portfolio, right? Okay. So, so what is the risk of this complete portfolio? Again, very similar formula, right? Just like stock D and E. Weight in stock. So factors that you need to take into account: weight in the two stocks, the variances of the two stocks, and the third important factor when we calculate the risk is the covariances, right? But here, the other asset is a risk-free asset, right? So which means its riskiness is zero. Its variance is equal to zero. So if we replace this, okay, if we replace this variance, if we put variance of the risk-free asset equal to zero, which is because it's close to zero, right? It's risk-free. So if we put it equal to zero in the above formula, what are we left with? Okay, so we are left with this first term, weight in the risky portfolio, share of the weight in the risky portfolio, times the variance of the risky portfolio, right? The second term becomes zero, right? This second term becomes zero. Why? Because sigma f, right, is variance of the risk-free asset is zero. So the second term becomes zero, right? What about the third term? What about the third term? The covariance is zero, right? Because there is no covariance between the two. Okay. So the third term also becomes zero. So what are we left? We are left with a very simplified version of it, right? So variance of the complete portfolio is equal to square of the weight in the risky portfolio times the variance of the risky portfolio. Okay, and if we take the square root of it, we get to the we get the standard deviation of it. Okay, is this clear? Right? Is this clear? Yes. Good. Okay. Good. So now we have an equation for expected return of the complete portfolio and an equation for the risk of the complete portfolio, right? So what I'm going to do next is to combine these two. The combination of these two will lead us to this capital allocation line. So we get an expression that relates the expected return of a portfolio to the risk of the portfolio, right? Okay. So the first equation bit is the expected return of the complete portfolio, which we just, uh, you know, uh, which I just showed you right here. Okay. The second term is the risk of the complete portfolio, right? Okay. So so from here we can calculate what is the weight in the risky portfolio. What is YP, right? So we can rearrange this. So YP is equal to standard deviation of the complete portfolio divided by standard deviation of the risky portfolio. And we can replace this YP in our expected return of the complete portfolio equation. Okay? And all I've done next is rearrange this, right? Okay? Now this looks much more like CAPM. Okay? Now this looks like much more like CAPM. So what is the expected return of the complete portfolio? It's the risk-free asset. Is the return on the risk-free asset plus the excess return because you have chosen to invest in a risky portfolio, right? So we call it excess return. A return on the risky portfolio minus the risk-free return is what we call the excess return on the market because you have chosen to invest in a risky portfolio, right? Scaled by, if it's scaled by this term, right? Okay, so you multiply it with the standard deviation of the complete portfolio and divided by the risk of the standard deviation of the risky portfolio. Okay, good. Again, this blue line is again a rearrangement of it. This again looks very similar to CAPM. So this is what we call as capital allocation line. Okay, so how would you interpret this? Right? So the return on this complete portfolio, okay, which is a combination of risk-free asset and a risky portfolio. So if you put zero, if you put zero in the risky portfolio, right? If you put all of your investment in the risk-free asset, what will be your return? RF. Okay. But if you choose to invest in a risky portfolio, and why would you choose to invest in a risky portfolio? You will only choose to invest in a risky portfolio if you get compensated for taking on the higher risk. Right. Okay. So the capital allocation line is a line on which we can have all risk return combinations in a risky portfolio and a risk-free asset. The expected return on the complete portfolio is equal to the risk-free rate plus an additional reward to risk ratio, which we call the Sharpe ratio. Okay, so this expected additional return to the risk ratio is what we call the Sharpe ratio. Okay, good. So this line here, this represents the capital allocation line, right? So it's so what does it show? As you take on more risk, as you increase the risk on the horizontal side, the expected return should also go up. So as you take on more risk, as you invest more in a risky portfolio, your expected return should also go up. Okay, so the slope of this line is what we call the Sharpe ratio, right? The reward to risk ratio. Okay, so if I take you back to this equation, right? So this term here, this term, right, is the Sharpe ratio, which is the compensation that you are getting for taking on for investing in a risky portfolio. So what is the compensation? The excess return. Okay, what is this compensation? Excess return. Expected return on the risky portfolio minus the risk-free rate. This is the excess return. Okay, divided by the risk of the portfolio, risky portfolio. So excess return over the risk of the riskiness of the portfolio is what we call the Sharpe ratio. Okay, good. Right. So let's take an example. Okay, to calculate this complete portfolio. So assuming investors want to invest in a risky portfolio and a risk-free asset, right? So if you look at the first bit here, risky portfolio, 15 will return. Expected return of the risky portfolio is 15%, and the risk of this portfolio is around 22%. The risk-free asset offers 7%, and given it's risk-free, so its risk is 0. Okay. So now you want to create this complete portfolio. So what do you need to know? How much you're going to put in risk-free asset and how much you're going to put in the risky asset, right? Okay, so we have to calculate YP and once we know what we are going to put in the risky portfolio, we can work out what are we left with to invest in the risk-free asset. Right, okay. Good. So using the formulas that we have calculated or driven earlier, right? So expected return of this complete portfolio, right, is the weight in the risky portfolio, weight in the risky portfolio, YP, times the expected return of the risky portfolio, plus the weight in the risk-free asset, which is 1 minus YP, okay, times the expected return of the risk-free asset. So we can calculate the expected return of this complete portfolio, right? okay, which is simply the weighted average. More importantly, we can calculate the risk of this complete portfolio, right? We know from above, right? So when we have a risk-free asset, we get a simplified version of this. Okay. So using this equation, we can calculate the risk of the portfolio. Okay. Good. And based on this, we can calculate, how much we're going to put in the risky portfolio. And once we know how much we're going to put in the risky portfolio, we can calculate what is left for us to invest in the risky portfolio. Okay, so this term in the bracket, as I mentioned earlier, is what we call the Sharpe ratio, right? So here, what do we have here? Excess market return. 15% return of the risky portfolio minus the return the risk-free rate, right? So the difference between the two is the excess return because you have invested in a risky portfolio. And we divide it by the risk of the risky portfolio, which in our example is 22% here. Okay. So this term in the bracket is what we call the Sharpe ratio. So when will you get the highest return? When the Sharpe ratio is higher or lower? What is your objective? Would you want to increase the Sharpe ratio or would you want to decrease the Sharpe ratio? The numerator here is the excess return, right? So you would want to maximize the excess return, right? So you would want the Sharpe ratio to be as high as possible. Okay, so let's look at the same thing in the form of this capital allocation line, right? Using the same numbers. Right. If you put everything in the risk-free asset, what will you get? You'll get 7%, right? If you put everything in the risk-free asset, what will you get? Point P, right? So you get 13%. Okay. And the line that connects the risk-free asset with that risky portfolio shows the combination of these two assets. That would depend upon how much you're going to put in risk-free asset and how much you're going to put in the risky portfolio. Okay. And if you look at this gap, this difference, right? The difference between the return on the risky portfolio and that of the risk-free asset, which we call the excess market return. And if we divide it by the by the risk of this risky portfolio, which in our example is 22%, and that's what we call the Sharpe ratio, right? Okay. So what do you want here? You would want this slope, right? It's the slope of this line, right? Which we call the Sharpe ratio. So as an investor, would you like this slope to be higher or lower? What do you want this slope? What do you want this slope to be? Higher or lower? You would want it to be higher, right? Because okay, let's actually draw it, right? Okay. Okay. So with the current example, right? This is our Sharpe ratio, right? 0.59. Okay. Okay. Let's. Okay. Good. Let me just. Okay. So this was our original example where the return on the risky portfolio was 15%, right? So all I'm going to change now, I'm going to change this 15% to 20%. So here. So that's the only change I have done, right? The rest is identical to the previous example. If I change that 15% to 20%, right? My new Sharpe ratio is this one. 13% over 22%. How do I get 13%? It's the excess return on the market. Return on the risky portfolio, 20%, minus the return on the risk-free asset, which is 7%. So the difference is 13%. So at the excess return on the market divided by the standard deviation of the risky portfolio, which is 22%, we get a Sharpe ratio of 0.59. Okay, So now you can see this on the slide, right? The original scenario, the blue line, and then the red line shows when you have changed the expected return of the risky portfolio to be 22%, to be 20%, right? So which point would you prefer? This this point here, okay? So this point, or would you prefer this point? If you look at this, for the same risk, right? For the same risk, the return is higher here. Okay, good. So you would want this Sharpe ratio to be as high as possible because for the given level of risk, it shows, it gives the higher return. Okay, so the slope of this red line is much steeper. So the slope of blue line is 8 over 22%, and slope of red line is 13 over 22%. So the steeper the slope, uh, the higher is the Sharpe ratio. Okay, good. Right. Okay, we still have 5 to 10 minutes. Okay, so let's continue with this example. Okay, so we want to extend our analysis to construct portfolio of risk-free asset and portfolio of risky asset, not just the risky assets now. Okay, so assuming that we want to combine the portfolio of stock D and E, which we have looked at in the previous lecture, previous part of this lecture, and the risk-free asset. And here we assume that risk-free asset has a return of 5%. Okay. So these are the two stocks that we work with, right? Stock D and stock E, their expected risk and returns are given. And we assume that the correlation between these two stocks is 0.3. Okay, so given that we know the risk, we know the expected returns, and we know the correlation between the two, we can calculate combination of these. We can calculate portfolios based on combination of these two assets. So instead of calculating it numerically, I've shown it graphically here. So what do we have here? So on the horizontal side, we have the risk of the portfolio, and on the vertical side, we have the expected return. Okay, and then we have this curve that shows all the possible combinations of stock D and stock E. And both stock D and stock E are risky assets, right? Okay, so you can think of this as being the efficient frontier of stock D and E, right? So these are all the possible combinations that you can create by combining stock D and stock E by investing different amounts, by changing the weights of investments. Okay, so if you look at point A, for example, right, the expected return of point A is 8.9%, and the risk of this portfolio is 11.45%. So you can see this is the minimum variance portfolio, which we calculated earlier. I showed it to you earlier as well. So point A is the minimum variance portfolio. And if you look at this point B, right, point B is above this point A. So it has a slightly higher risk, right? Point B has a slightly higher risk, but point B is also above point A. So it gives a higher expected return as well. So expected return of this portfolio B is 9.5%, but the risk is slightly higher as well, which is 11.7%. Right? So all these points on this blue line represent a portfolio, combination of these assets. What about this point E at the top? Is that a portfolio? Point D at the top, is that a portfolio? Point E on this blue line, is that a portfolio? Yes. Okay, because it's a combination of stock D and E, right? So anything on this blue line is a combination, right? So you can see the expected return of this point E is around 13%, but the risk is much higher as well. Okay, so which portfolio would you choose? You would choose any portfolio on this blue line. but not below this point A. Okay. If you go below this point A, what will you have? Let's say point D, for example, right? Point D. Point D has the same risk as point B, right? Can you see that? Point D has the same risk. Portfolio D has the same risk as portfolio B. Okay. But portfolio D offers you a much lower return as compared to portfolio B. Okay. So if you have a choice between portfolio D and portfolio B, you should always go with portfolio B. Great. Okay. So if you combine these portfolios, if you combine these portfolios with the risk-free assets, RF, and in our example, RF was 5%, right? So what I've done, I've joined these points, these portfolios with the risk-free asset. Okay, risk-free return on the risk-free asset is around 5%. So these black lines, right, simply join the risk-free asset, combine the risk-free asset with this risky portfolio. So which one would you prefer? So now you can see we have two capital allocation lines, right? For A, for portfolio A, and for portfolio B. So which one has a higher slope? Which capital allocation line has a higher slope? B, right? Okay, so which means the Sharpe ratio is greater when you combine portfolio B with the risk-free asset. Okay, so Sharpe ratio is higher, so that's why you should choose portfolio B over portfolio A, right? But can you increase the Sharpe ratio further? Can you increase this Sharpe ratio further? Can you increase the slope further, right? Okay, so I want you to think about this. You can shift these black lines to the left until it becomes tangent to this blue line. Okay, and that will be the most, that will give you the optimal combination of the risky portfolio and the risk-free asset. Okay, so essentially, as you're moving these black lines to the left, you're increasing the Sharpe ratio. Okay, so you will, the greater the Sharpe ratio, the more you're increasing the expected return for a given level of risk. Okay, so let's stop here, and then we will continue from here in the next session.